Hello friends, welcome to EMTECH channel. This is yet another video in this channel. In this video, we are going to see about tap changes. What is Onload Tap Changer with the on-site practical demonstration, and in this video, we are going to cover what are the basics of the tap changer and its types and circuit explanation and its practical working. Now let's move on to the video. What is tap changer? By definition, tap changer is a device that is used to regulate the output voltage of a transformer. Why we need to regulate the output voltage? Because all the loads will be connected to the output of the transformer, that is the secondary side. So important that we have to regulate the output voltage of the transformer. If not, the devices may get malfunction or get damaged due to fluctuation of the voltage, if any, from the output side of the transformer. How it does? It does this by altering the number of turns in one winding. In this example, we are going to see that a tap changer that is connected to the high voltage winding and keeping the low voltage winding constant. In most of the cases, the tap changer will be in LB winding, low voltage winding also, but in this case we are going to see a tap changer that is connected to the primary side of the transformer. So in this case, the number of turns in one winding means number of turns in primary winding, and thereby changing the turns ratio of the transformer. By varying the turns ratio of the transformer, we are varying the primary voltage to the transformer, because number of turns in primary is directly proportional to the voltage in primary. We will see this by a simple calculation. V1 is the voltage in primary, V2 is voltage of secondary, N1 is number of turns in primary, and N2 is number of turns in the secondary. Actually, there are two types of transformer tap changes. One is on-load tap changer, another one is off-load tap changes. Now we will see the Excel sheet to understand how the variation of the turns in one winding will reflect the voltage change in the respective winding. And this is the Excel sheet which I was talking about. Here V1 is the voltage at primary. In our example, we took the primary voltage as 33 kV and secondary voltage as 11 kV. Voltage at primary will be variable as per the incoming supply, as per the EB side, or there will be some fluctuations, as you know. V2 is the voltage secondary. It should be maintained constant because it directly goes to the load. And N2 is the number of turns at secondary. Here it is given as 25, but in practical case it will be different. You can see here the primary voltage is now 33,000 and secondary voltage is 11,000. Number of turns at secondary is kept constant as 25. In this case, for this parameters, we will be getting number of turns at primary as 75. In case if the voltage is fluctuating and the voltage is increased from 33,000 volt to 34,500 volt, you can see keep the secondary voltage as constant, the number of turns in primary will increase to compensate the increase in voltage, and hence now you can see the number of turns at primary increased to 78. Suppose if the voltage drops from the rated 33 kV, what will happen? We will see that also. In that case also, if the voltage drop to 32,000 volt, what happens? Again the number of turns getting reduced to compensate the reduction of voltage in primary and to make the secondary voltage constant. So you can see clearly from here that number of turns in primary is directly proportional to the voltage. Now we will see the block diagram of a circuit with the tap changer. ROIB, we have ROIB, tap section for R phase, tap section for Y phase, and tap section for B phase, and these three put together comes under tap changer unit. And this tap, from the tap changer, the winding is connected to the transformer primary side, and this is the secondary side. You can see here, and the secondary side is connected to the load. Schematic circuit of tap changer, actually it is for understanding purpose, and in actual case the circuit of the tap changer will vary, and I will show you in the next coming slides. For ROIB, and here we have a tap 1 as the topmost and tap 5 is the bottommost, and there are 3 taps: tap 2, tap 3, tap 4 in all 3 phases. And for example, now I am connecting tap 1 and tap 2. So you can see the most of the turns is 50% of the taps is excluded. So what will happen? As the number of turns in primary winding is got reduced, so the voltage will also be definitely reduced. In this case only 50% of the primary winding is used. In this tap 3 you can see still some more taps are included but not fully. In this case 60% of the primary winding is used, and when connected to tap 1 and tap 4 we can see still more tappings are included but not full, and in this case 70% of the primary winding is used. And when connecting tap 1 and tap 5 we can see 100% of the primary winding is used, and this is the highest voltage we can get from using this tap changer. This is the interpretation of a linear type tap changer circuit from a transformer nameplate details. Transformer nameplate, the onload tap changer circuit will look like this only. And in this type there are in this winding you can see there are two parts in the winding section. One is the main winding and another one is the regulating winding. The main winding is some of the portion of the transformer winding will be kept constant. For in that there will not be any tappings, and that is called as a main winding, and the winding section in which tappings are there, and it is called as a regulating winding. Unfortunately the tapping numbers are not clear, and hence I have marked it. You can see here, and this main winding you can see in the bottom it is the tapping number 2, and the main winding the top is 14, and in this reserve winding you can see this tapping is 3, means 3 4 5 6 7 8 9 10 11 12 13, and this is 14, and first number 1 is here and the number 2 is at the end, and in between between windings are number 3 to 14. And you can see here total 14 tappings are there from 1 to 14, and the tapping is made on the HT side and not on the LT side. It can be seen clearly from this nameplate. You can see here HV volts are given as variable and LV volts are kept standard. So it means that the tappings are present only in HV side winding of particular this type of transformer, not in the LV side. And next you can see from the nameplate, if I make a tapping between 13 to 14 it gives the highest voltage, and if I make a tap between the taps number 3 and 14 it gives the lowest voltage. How? You can see here this is 13 and 14. If I connect this switch, it's called a diverter switch, and if I connect the switch from here to here, what happens? The supply will flow through this, and it utilizes full 100% of the reserve winding, regulating winding, and then from 13 it travels again to 14, then to 2, and it moves on to next winding. As the number of turns are highly utilized, fully utilized, the voltage that it can give will also be more, as number of turns is directly proportional to the voltage. Suppose if I make contact between 3 and 14, what will happen? You can see if I move the switch to here, so supply will come from here to 3, and it skips all the windings between 4 and 13, and it directly goes to 14, and hence it gives the lowest voltage, because the number of turns, active number of turns that being utilized is become less, and hence the active voltage will also be less. Before moving to the visual, it would be better to know about the fixed contact and moving contact and how it would look like before seeing the video, so that you will get a better understanding. And in this video we are going to tap changer, which will have a moving and fixed contact like this. This copper strip is called as a fixed contact, and for each tappings there will be a fixed contact, and this set of 3 rollers is called as a moving contact. The roller at first and the roller at last will act as a making contact or breaking contact, and the roller at center is called as a resistance contact. It is called as a resistance contact because the circuit resistance will be connected to this, means the tap changer resistance will be connected to this, and the amount of resistance connected to the each roller is printed in the tap changer nameplate details itself. And at a time only one roller, that means either first roller or the third roller will serve as a making contact or breaking contact. In other terms, if first roller act as a making contact, third roller will be a breaking contact, and suppose if first roller is act as a breaking contact, the third roller will act as a making contact. It depends on the direction of rotation of the tap changer, whether you are increasing the tap or decreasing the tap. And the roller which makes contact with the fixed contact at first is making contact, and the roller which leaves at last the fixed contact is called as a breaking contact. For example, let us consider I have a tap changer with two taps, tap 1 and tap 2, and now I am going to change the tapping from tap 1 to tap 2. What happens once I change the roller at first, and the moving contact will leave the tap 1 and reaches the tap 2. Until the tap first roller reaches the tap 2, the last roller will still remain in the previous tap, that is in first tap itself, and the middle contact, that is the resistance contact, will be in halfway mark. This happens because under the load, if the circuit opens suddenly, what happens, arc gap will form, and this will cause the arc to generate. To avoid this, the tap changer, onload tap changer uses a phenomenon called make before break, because make a contact with the next tap before breaking the current tap, and this is called as the make before break phenomena. Hope you liked the video, and if you like the video, do like, comment, share and subscribe the video, and don't forget to press the bell button next to it so that you will get updated videos on time.